Hello students, I welcome all of you to this statistics session for grade 13. The topic which we are going to start with is representation of data, and in this lesson you are going to learn how to differentiate between the two types of data, namely discrete and continuous. Secondly, you are going to learn about raw data, and lastly you are going to learn how to draw a histogram from a given grouped frequency distribution. Right? So let's start. What are the types of data? Data, or simply information, is classified in two categories, and the two categories are discrete and continuous data. Now, how can we distinguish, how can we differentiate between these types of data? Let us see. Whenever we talk about discrete data, it refers to information which take integer values only, meaning they are whole numbers. For example, if I tell you the number of people who are affected by COVID-19, the number of people, right? It can be 10, 20, it can be 1, 2, 3, it can be in terms of thousands. The number of people has to be whole numbers, meaning integers. You can't have number of people as decimals or fractions. So number of people is a form of discrete data. Another example would be the number of cars, the number of defective bulbs. You see, these can't take fractions or decimals, they have to be whole numbers. So these are discrete information, discrete data. Now on the other side we have continuous data. Continuous data can be integers, whole numbers, as well as decimals. Right, this is the difference between continuous and discrete. Discrete, they have to be integer values only, whole numbers, whereas continuous can be whole numbers as well as decimals. For example, the height of a person. Height, when you measure the height of a person, you can obtain it as whole number, of course. For example, 170 centimeters, or sometimes you will obtain it as decimal, 171.4, and so on. Right, you see the height, it can be a whole number or it can be a decimal, so it forms part of continuous data. Another example would be the time taken by an athlete to run a race. Time, when you measure it using a stopwatch, you can obtain it to be a whole number or decimal. The same applies for distance covered by a bus. Distance still can be a whole number as well as a decimal. So these are examples of continuous data. You have to know how to make the difference between these two types of data. Right? Now there is another term that you have to know, which we call it raw data. Raw data. Raw data means data that has not been organized in any form. Right? It is data in original form. Right? Or simply it is a set of unsummarized data. What do we mean by these? For example, here I have collected the marks scored by a group of 20 pupils in a test, and the test was out of 10 marks, right? So in the first row here, we have the marks of 10 pupils. We can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have the marks of 10 pupils. And in the second row also we have the marks of other 10 pupils. So in total we have the marks of 20 pupils. Now why do we call this raw data? This is raw data. Why do we call it raw data? Simply because it is the data which has not been organized, neither in the form of tables nor in the form of charts, right? It is data that has just been collected in the original form. So remember this, raw data is simply data in original form, data that has not been organized in any way, right? So we proceed now with a group frequency distribution, right? Whenever we have a grouped frequency distribution, it means our information, our data has been grouped into intervals which are called classes, right? Now the ways of presenting grouped frequency distribution, right? It is through a histogram and a CF curve, cumulative frequency curve, right? These are two main ways of presenting grouped data, right? Now let us take a look at this example. Here we are given the weights of 70 students, right? And the results are given in the table below, right? The first row of the table, it denotes weight, which is in kilograms, right? And here we have what we call intervals. This is the first interval from 30 kilograms to 40 kilograms. Then we have another interval from 40 to 50 kilograms. Then we have another interval from 50 to 70, right? And for each interval we are given the number of students, meaning the frequency, right? For the first interval 30 to 40 kilograms, we have 20 students whose weight are from 30 to 40 kilograms. For the second interval, the frequency is 24. We have 24 students in this category, 40 to 50 kilograms. And lastly, we have 26 students in the category from 50 to 70 kilograms, right? Now, as you can see, our information has been grouped in intervals. So this is what we call a grouped frequency distribution table, right? Now, let us present this grouped frequency distribution on a histogram, right? So this is the same table, but I have added these two columns. Why I have added these two columns? Because to be able to draw a histogram, what are the informations that are required? The horizontal axis, of course, here it will denote the weight of the students in kilograms. We already have the weight. This is not a problem. Now the vertical axis is the axis of frequency density, right? We have to obtain the frequency density of each interval. And how do we calculate the frequency density? By taking the frequency of the interval, we divide by its class width, right? That is why I have included the column of class width. Okay, so let us fill in the table. Let us take the first interval from 30 to 40 kilograms. 30 is called the lower class boundary and 40 is the upper class boundary. Right? To obtain the class width, always you take the upper class boundary, you minus the lower class boundary. Right? So for the first interval, the class width is simply 40, which is the upper class boundary, minus 30, which is the lower class boundary, and it gives 10. Right? Similarly, for the second interval, 40 to 50, the class width will be 50 minus 40, which gives 10 again. For the third interval, from 50 to 70, the class width is 70 minus 50, which is 20. Right? Now that we have completed the class width, it is then only that we can find frequency density. So let's do it. Frequency density, we have to apply this formula. Frequency divided by class width. So the first interval, the frequency is 20, divided by the class width, which is 10. It gives a frequency density of 2 or simply 2.0. For the second interval, the frequency is 24. We divide by the class width, which is 10, which gives a frequency density of 2.4. And the third interval, the frequency is 26. We divide by the class width, 20, which gives 1 decimal free. Right? All we have to do now is to display this information on a histogram. Right? So here we are. We have the weight. The weight has to be on the horizontal axis. So I include the weight in kilograms, starting from the least value, which is 30. So on my horizontal axis, I will start with 30. Then I must adopt a scale for this axis. I know that the class width is 10 for the first interval, 30 to 40. So I choose 2 centimeters, meaning 2 big squares, to represent an interval of 10. So here is 40. The second interval from 40 to 50, still a class width of 10. Again I leave 2 centimeters or 2 squares. I insert 50. Then last interval from 50 to 70, meaning a class width of 20. So I continue 50, I leave 2 squares. This is 60. I leave 2 squares again. Then I reach 70. Right? So I have completed the horizontal scale for the weight. Now frequency density has to be on the vertical axis, right? Okay, right. For the frequency density axis, I will choose which scale. Let us see. So we are going to choose the scale of 2 centimeters, meaning 2 big squares to represent 0.5, right? So each time we are moving by 2 squares, we have to add 0.5. So this becomes 1.0. This is 1.5. Here is 2.0, and we end up with 2.5. Right? All we have to do now is to draw the individual bars or the individual rectangles of the histogram. So for this we have to use a ruler, of course, right? The first interval is the interval from 30 to 40, and the frequency density is 2.0, right? So we take our ruler. On the horizontal axis we are at 30 here. We move our ruler till we reach 40. Here we are, exactly at 40. Now we have to go up till we reach 2.0. 2.0 is here. Okay, so we draw a vertical line. Right, now we rotate our ruler, of course. And we draw the horizontal line at 2.0. So this completes the first bar of the histogram. Right? We repeat the same steps for the second interval from 40 to 50. We have to go up to a frequency density of 2.4. Again our ruler comes into play. Right, interval from 40 to 50. So this is 40, 50. We are here. We need to go up till 2.4 this time. So 2.4 is here. Right, so we draw a vertical line. Then we, right, and now we rotate our ruler. Right, this is the second bar. Now we have to complete the third bar from 50 to 70, a frequency density of 1.3. Let us locate 1.3 on the vertical axis. This is 1.1, 1.2. So 1.3 is here. Right? Again our ruler. It is already horizontal, so I will place it on the 1.3 mark. This is here. I draw the horizontal line up to 70, and now I rotate the ruler, right, and here we are with our histogram, right. So this is how we draw a histogram by inserting frequency density against the interval, right. Now there is something very important that you have to know concerning histogram. It is simply the area of each bar. The area of each bar gives what? Right? Suppose I take the first bar, the first rectangle, right? I calculate its area. The area of the first bar will be simply the area of the rectangle, right? Which is length times width, which gives, what is the length of the first bar? It is from 30 to 40. The length is 10. And what is the width? The width here is simply the height of the bar, and the height is simply 2.0, right? So the area will be simply 10 times 2.0, which gives 20. So let me write it here. Here I have an area of 10 times 2.0, which is 20. Now if I do the same for the second bar, what will be the area? The length, which is from 40 to 50, the length is 10. So I take 10 times the height. The height is 2.4, which gives 24. And what about the third bar, the third rectangle? What is the length? It's from 50 to 70, meaning the length is 20 times the height. The height is 1.3, and this gives 26. Now what are these values? 20, 24, 26. Are they found in the table? Let us see. 20, 24 and 26. Here they are. 20, 24, 26. So the area of each bar gives, in fact, the frequency of the class it represents, right? So we write down the area of each bar gives frequency of the class it represents, right? This is very important. Always keep this in mind, right? And another thing that you must observe, for a histogram, all intervals should be continuous, right? You can see it in the drawing itself. The first interval was from 30 to 40, and the second interval was from 40 to 50. right? You see where the first interval ends, the second interval starts there itself. And in this table also you can observe this. If you take the first interval ends at 40 and the next interval starts at 40. For a histogram, it has to be like this, where the first interval ends, the next interval must start with the same value, right? So now let us take a look at this example. In this example, we are given the masses to the nearest gram of 32 letters delivered by postman is given in the group frequency distribution table below. So this table shows the mass of letters in grams in the first row and the number of letters, which is the frequency, in the second row, right? So we are given the mass of letters and the number of letters. Let us look at the intervals. The first interval is from 21 to 40 grams. The next interval is from 41 to 60 grams. And the last one from 61 to 80 grams. What can we observe? Right? We simply observe that the intervals are not continuous. The intervals are not continuous, right? Because if we take the first interval ends with 40 and the next interval starts with 41. So where the first interval ends, the second interval does not start with the same value, right? This is why we say that the intervals are not continuous, right? And the question says we have to draw a histogram to display this information, and like we have said before, to be able to draw a histogram, the intervals have to be continuous. So in such a case, we have to perform an adjustment of the intervals. So we need to perform adjustments of the intervals. How can we do this? Let us see. We take the first interval from 21 to 40. It ends with 40. Right? The next interval starts with 41. What we do, simply we add these two numbers, 40 plus 41. Then we do an average, meaning we divide by 2. This will give 81 divided by 2. We have 40.5. Right? Now 40.5 will become the upper class boundary of the first interval. Right? So the first interval will end with not 40 but 40.5. Right? The old upper class boundary was 40. Now it has to be adjusted to 40.5, meaning the adjustment will be an adjustment of 0.5. Right? Now when we talk about adjustment, it has to be before and after the boundaries, meaning you have to put plus and minus. Right, so let us do the adjustments. Right, firstly we choose the lower class boundary, which is 21. With 21 you subtract 0.5, which is the quantity for the adjustment. This gives 20.5. So the first interval starts with 20.5. Right? Now with 40, you have to make an adjustment still of 0.5, but this time you add 0.5. So it will be 40.5. Right? This is how we do the adjustment with the lower class boundary. We subtract, and with the upper class boundary we add. Right? Now doing this for the second and third interval is going to give us 40.5 up to 60.5, and the third interval from 60.5 to 80.5. Now what do we observe? We observe that where the first interval ends, the second interval starts with the same value. So now our intervals are continuous. So now we can draw the histogram. Right. So before drawing the histogram, we have to complete the column of class width to give frequency density. So let's do it. The first interval is from 20.5 to 40.5. So the class width is 40.5 minus 20.5, which gives 20. The second interval is from 40.5 to 60.5, which is a class width of 20 again. And the last interval from 60.5 to 80.5, again a class width of 20. So here we have a situation of same class width, equal class width, right? And the frequency density, we obtain it by taking frequency divided by class width. 18 over 20 gives 0.9. The second one, 10 over 20 gives half, which is 0.5. And the last one, 4 over 20 gives 0.2. Now all we have to do is to display this information on a histogram, right? So our horizontal axis will denote mass, so we write it here. Horizontal axis represents mass in grams, right? And the interval starts with 20.5, so we start with 20.5 on the horizontal axis. Again we have to adopt the scale. I will select 2 centimeters, meaning two big squares, to represent a class width of 20. So 20.5 to 40.5, this is the first interval. Then the second interval, 40.5 to 60.5, again 2 big squares. Then the last interval, 60.5 to 80.5, again 2 centimeters or 2 big squares to represent a class width of 20 again, right? So this is it on the horizontal axis. Now on the vertical axis, I will choose 1 centimeter or simply 1 big square to represent a frequency density of 0.1. Right? Again one big square 0.2, another square 0.3, and so on. See 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. This is the axis of frequency density. Right, so we use our ruler again to complete the bars of the histogram. Right, so the first bar will be for the interval 20.5 to 40.5, and we have to reach up a frequency density of 0.9. 20.5 to 40.5, 0.9. Okay, so this is where the first bar reaches, and now we rotate our ruler again to complete the first bar. So here we are, right? The first bar completed. Like this, we carry on to complete the other two rectangles of the histogram. So this is it. We have completed the histogram for this grouped data, right? And the question also says we have to write down the model class, right? For a histogram, the model class is the class which has the highest frequency density. So let us write it down. The model class is the interval with the highest frequency density. So in our case, the highest frequency density is 0.9, and it is for the interval 20.5 to 40.5, right? So this corresponds to the interval 20.5 to 40.5, which indirectly is the interval 21 to 40, right? So this is how we find the model class. So this is it, the end of the first session.